Is my screen visible to all of you?
Yes, sir.
Yes, sir. Yes,
sir.
Okay. So again, we started discussion last class. We are continuing with that, but let me put some of the points or some of the concepts because I think last class who was asking, Samrat or someone was asking how the transactions happen, right? Because if you remember what we told in the last class or the before that also in the first class itself, blockchain is a collection of blocks, right? Connecting different blocks, and each block is a list of transactions, right? So we are looking into the financial transactions. It can be land records also, need not be necessarily the financial transactions, right? So if you have watched that video which I had shared, right, lot of conflict in India is happening in rural area due to this land records, right? Land records are not digitized. A lot of forgery happens, right? If you see almost every house, almost either your house or your relatives house, there will be always certain land dispute, right? Even if you have paid money, done everything legally, right? Still there will be somebody saying that no, this land belongs to me. So lot many land disputes, right? Not only in rural villages, even in the cities, metros, right? So that is one big challenge in India, right? Digitization of land records. Second part is authenticity, right? So that nobody can go back, because most of the times what happens, somebody who owns the land dies after 1 or 2 generations, people will go back and change documents, right? So their blockchain can be utilized, right? So if you see that video, that person who used to work in Mahindra, he is telling about how many suicides happened due to that, right? Because somebody, just imagine a farmer who has a land and right now he doesn't have the ownership of that due to just a missing document, right? So lot many applications. So this blockchain part, if you can able to implement that, right? No record can be like nobody can tamper with those records, right? Going back, right? So that will be a very good application. If some of you want, you can put a use case on that also, your project work, right? So the idea is try to do something which will be helpful going forward, and you can discuss that in case somebody asks you what kind of interesting thing project you have done. You can talk that in your during your interview. So what we have discussed, like if I go back a little bit, last 2 classes, we said that blocks are nothing but list of transactions. Then those list of transactions get encrypted in a hashing algorithm, secure hash algorithm, SHA-256, right? It gets into a 256 bit or 32 byte kind of configuration, alphanumerical configuration, and that cannot be changed, right? That cannot be hacked, right? So that is the fundamental of whatever we have discussed so far, right? Again, we discuss how that puzzle is getting solved, right? Yes, yes, Ankita. Hello. Hello.
Sir, as you talked about land maintaining. Hello, sir.
Yes, yes, go ahead, go ahead. I can listen.
Sir,
Yes, I
as you
can.
Mentioned, as you mentioned the about the recording land in blockchain. So if the land will be transfer of ownership will be there, or sales, the land is sold to someone else, so then records, we have to change that record, right? The ownership has been transferred or something like that.
Exactly. So that ownership change need to be recorded in blockchain, right? So that is the part I'm telling about, right? So let's say I own a land, or let's say my grandfathers used to own a land, right? When it is getting transferred to my father or from my father to me, right? If it is getting recorded in a blockchain, right? So block one, let's say it was a transaction happened, somebody, my grandfather bought 30 years back, 50 years back, 60 years back, right? Now we may be at block number 1 lakh or 2 lakh, whatever the current block is. So now let's say grandfather has given that to my father, right? So that transaction will get recorded here, right? So this is a collection of blocks, and it is not only for my family, right? Whichever, like, because it is one block is not only for one record, right? In one block there can be many records, right? Records of different families. But what will happen once those records are getting listed in a block, right? In a blockchain, right? Nobody can go back and change or tamper that. Right now it is happening a lot. Right now what happens, you will create a forgery document and say that, okay, no, he has sold me that document, and you will go to a courtroom, and the case will be dragged for 10 years or 30 years, right? Because you have a document, forged document maybe, but you have a document, right? So what you are asking is, that transaction itself, when I say transaction, right? So I'm selling a land to somebody else. That if it is, so all these transactions are getting recorded in a blockchain, then nobody can play it with. Nobody can change those earlier records, right? So that is the part I was talking about. Is it something you were asking or something else you were asking?
Yes, sir, the same thing.
So I hope that is clear. So when I say transaction, we saw that okay, I am paying you 100 rupees, right? Rather than a monetary transaction, finance transaction, if I say I'm selling you a land, right? So that is also a transaction, right? So now ownership is transferring from person A to person B. If that is recorded in a blockchain, in a specific block, right? Then after 20 years or 10 years or 30 years, that person B sold that land to somebody else. Again, that will be recorded in another block, right? So what happens? That will be a continuation of the blockchain. So nobody can go back and change those records. But now what happens? If you see, a lot of dispute happens because due to forgery in documents, people go and kind of do all these kind of things, forgery and all those things, right? So that can help us actually. Was it clear?
Yes, sir.
So let us understand the first concept, right? Because whenever we talk about blockchain, right, or block, right, it is always about the transactions, right? There is a list of transactions and it is getting into a block, right? Now the question happens, I think, who was asking Samrat or somebody, how to secure the transaction, right? If I'm saying that, okay, I'm sending you 100 rupees, think about in this way. You don't know how much money I have in account. That is not a lot of money, but you don't know the exact number, right? It may be 1,000 rupees, it may be 50,000 rupees, right? I also do not know how much money you have in account, right? Let's say I want to send you each one of you 10 rupees, right? I'll go to my bank through either through UPI or direct from account transfer, right? I'll make those transfers. Whatever money I have left in my account, right? That is again only confidence, that is confidential to me, that will be shown to me with a user ID and password, right? Whatever amount you have in your account after receiving those 100 rupees or 5,000 rupees, that is again confidential to you, and that is you can only see that, right? And let's say I have only 5,000 rupees and I want to send 10,000 rupees. It won't be possible. So somebody will say, why can not be possible, right? Because somebody will check who is that somebody, that banking institute or banking institution where I have my account, right? Somebody will look into my account, you have 5,000 rupees, they'll say that it is not possible, right? Right now we look into the blockchain part, right? What we are telling, there is no central authority because bank is taking some charges, right? Through ATM charges, through account management charges, maybe very few. Am I audible clearly?
Yes, sir.
It might be a very small amount we might not notice throughout the end of the year, but it is still a amount of money. Think about SBI or any bank, right? 30 crores, 50 crores of accounts. How much money they are getting into this, all the transactions and everything, right? Think about MasterCard and Visa, right? So they get certain amount of transaction fee, right? Banks get all those transaction fees, security fees to keep our account, right? All of this, right? Right now, what we're telling, if you implement a blockchain, there won't be any central agency like banks, right? The fundamental of blockchain started with that. And later on, we will tell that why it is not possible, why requirement of a central authority is required. Right now, the discussion is going on from government side on that. Anyway, so those things will cover later on. But let's imagine why, like the fundamental concept why blockchain or the Bitcoin and all those kind of cryptocurrency started that. We don't want to keep a central authority. We don't want to pay to transaction fees. Think about if I want to send money to USA, I have to fill 3 or 4 forms. I have to declare my income tax, like kind of IT returns and all those things, right? The person whom I am sending, his details are required, right? Lot many kind of constraints are in the system. Obviously, the constraints are there to avoid or to do away with corruption, right? But for a normal person like you and me, right? If you are like a kind of honest and we don't want to get into that part, but still it takes a lot of time to make a transaction to different countries, right? So blockchain helps in that sense, right? Blockchain helps that, okay, if I want to transact money from here to USA within maybe 60 minutes, that can be done. once the block transaction is over. But the problem with blockchain is that all the information, because who is doing the validation? The people who call themselves miner, they are solving certain puzzles. We have discussed that what is that puzzle, right? They are solving that puzzle, they are verifying the transactions and saying that yes, this person can transact, he has 5 bitcoins or 10 bitcoins in his account, then he can send 2 bitcoins or 3 bitcoins, right? So now what is happening? Everybody can see this person. So when I say this person, obviously they cannot know that whether this is Pius or who was Minhajul or Moni, whoever is in their list, right? But they know my address. They know my digital address. Okay, this person has 10 BTC in the account and sending 2 BTC to another account, 2 Bitcoin to another account, right? All the information is publicly visible. If you go like that, I showed you Blockchain Explorer. You can open Bitcoin, you can open Ethereum, and you can see that in each block what kind of transactions are happening, right? You might not know the exact person who is sending money to whom, but you know that from some address to another address certain amount of money has gone, right? So that is the open system. Blockchain is an open system where everything is visible to all of us. So when we have an open system, the additional security has to come. Then who will show that? Let's say if I can see that, okay, from address A to address B certain amount of money is going, rather than that address B, can I put my address as a miner? Let's say I am putting my, like I am part of that blockchain, I am mining in that blockchain. So what will happen? Let's say who is this first Minhajul is sending certain money to somebody else, let's say Asrit, right? So they have, so I don't know Minhajul, I do not know Asrit, so that is just a encrypted address, right? So I'll show you that address. So the link what I had sent you, that it shows some dummy addresses, right? So there are certain digits, alphabets and digits. So one address from another address, certain money of going, let's say 1 BTC, which is around 30 lakhs right now. So what I will do, rather than that address, can I change that address to my address? I'll hack that blockchain. I'll write some code. Rather than that amount of money, can I change that to my address? So that what happens when that 2 BTC goes, that money will come to me rather than going to him, right? Not only for 2 BTC, I can do it for everything, right? Thousands of BTC or 10,000s of BTC, whichever currently will be in circulation, right? So that is again one problem, because it is an open system. Everybody knows, even not the exact identity of a person. They know that some money is getting transacted from one person to another, and that is visible to me, right? If I change that, right? Think about in this way. Simpler example is this Google document. Right now I'm putting this evaluation. I'll share this today. Your attendance and everything, right? There is a Google document. You can be a viewer, so you cannot edit. But think about if I put that edit option, right? Now I have given certain marks to somebody else. Like all of you have got certain marks. Some of you say, because you, let's say you have the edit option, what will you do? You will change your marks. I'm just giving an example, right? So in that case, what will happen? Rather than somebody else getting that mark, you are getting that mark, right? So because this is an open system, this is visible to all but everyone, right? So Google document, which is shared across all the students, 45 students here, think that as a blockchain ledger, whether it is a Bitcoin, Ethereum, it is visible to all of you, rather than Ipsita, Minhajul, Moni, Muskan, whichever names are showing here in the participant list. Obviously, names won't be there. There will be certain alphanumerical addresses. So now what happens? Each one of you doing some transactions with each other, and that is getting recorded in that Google document, right? Now what will do? If I have the authority of editor, right? So what I can do, rather than somebody else sending money to somebody else, that address, I'll put my address, so that what happens? Anybody making any transaction, that money will come to me, right? So that is again a big challenge, right? Because if it is if we're making every transaction as an open system, can anybody play with it? Can anyone, because you are making open system, anybody can verify the transaction. Can that verify itself? So the question is, who will guard the guardians, right? So in ancient Rome, so that when democracy like kind of started, everybody debated on the starting of democracy. The first question was, if they are the guards, right, who will guard the guardians, right? Same question here. If miners are verifying all the transactions, who will now verify their activities in the blockchain? Can they change my transaction? Let's say you have sent 50 BTC to someone or 5,000 rupees to someone. Rather than 5,000, can they change 5,000 to 50,000? So basically those modifications, because as a miner, if they are able to see everything in the blockchain, can they modify those transactions, right? So that is a big question, right? If it is open system, anybody who can see it, can they modify it, right? So now the problem or the question comes, yeah, yes. Who is this?
Sir, I'm sorry to interrupt, but I think someone's there in the waiting room.
Yeah, there are 3 people. Okay. Yeah, I have allowed. So now the question comes how to validate or not validate, sorry, validation happens through this blockchain process, how to secure each transaction, right? Each transaction, let's say even the land records, even the financial transactions, even the sensitive data, let's say about your, let's say manufacturing data or the kind of, let's say if government projects are there, right? Your security data, right? Everything, right? How those transactions happening from person A to person B, certain information is going, sometimes information can be monetary, right? So in digital age, money itself is information, right? So I have 100 some details, 100 rupees. So physical money, if I do not send you those physical notes, digital itself, it is a some codes or some digital money itself is that, right? Certain code in a bank account that is getting transferred to account B, right? Can somebody hamper with those transactions, right? So that is something we'll discuss in the beginning. Then we'll go back and see that how that part will be included in the blockchain, right? So let us. So let's
Sir,
say.
I had one doubt.
Yeah, go ahead.
Sir, sir, you said that in blocks we can't. There's no particular address. Only there's alphanumerical address of each transaction or of a person. So can we use that alphanumerical part to identify certain person's identity?
So the question again, like the last class somebody asked, whether it is impossible, I'll say it is not impossible, but is it improbable? Like kind of with the computing power what we have, it will take a lot many years to like know if I have that alphanumerical code, right? Lot many. So
Yes,
that
sir.
I'll show you like how many security protocols are there. So again, it is not impossible if I have a large computing power like quantum
Yes.
computing. Maybe it will take few days, right? But current computing power, it is the amount of effort, the amount of time it will take. It doesn't make sense to do those kind of hacking.
Sir, and one more, sir. Sir, so you said that we can, say if we can hack the blocks and we can change the, suppose we can make, if we have only 2 Bitcoin, we can make into 100 or something like that. Sir, doesn't it require like more than 50% to make it real? But if we change only in one computer, then it shouldn't affect the others, other miners' data. Isn't
No,
that right?
I'm not talking about the block, changing the information in block before the transaction gets into, because see what happens, transactions happen, they get verified, then they get into block. In block, then they get into hashing. That means they get encrypted. So first step is if there is a transaction, let's say you send me certain money, somebody has to verify. What verification will happen? Whether this address is correct and my address is correct, whether you have that amount of money, right? So that verification happens. See, you have only, let's say 1,000 rupees and you send me 5,000 rupees, right? Which is not possible, right? If you have a bank account, the bank takes that ownership to verify that. But in a blockchain, who will verify that? Miners. So the first step is transactions get verified. Then verified transaction will get into block. Once they get into block, they'll get encrypted and they cannot be changed. Right now, what we are discussing, changing the transaction. Can I change the transaction? Yes, Raghav. Yeah. Hello, was that a question?
Yes, sir. Yes, sir. So I have a doubt, sir.
Yeah, go
So
ahead.
I'm audible. Sir, you told about transferring of land or ownership, land ownership transfer to blockchain also. Sir, is this the same way like the physical ownership transfer does, so like that in blockchain also happens, or directly we pay some cash transaction happens, and land also ownership transfer. How this happens actually?
See, that part still kind of not been, so there is no case study where both can be combined, right? So now what they're trying to do, right? So if I'm transacting, let's say one part is, let's say I own a land or my father owns a land. Now he wants to transfer that land to me, right? So it is just a non-financial transaction, right? The change in ownership, right? So that also can be included in a blockchain. So to include in a blockchain, I'll pay certain transaction fee. So my father will pay certain transaction fee to update that record in a blockchain. Let's say every land record in India is part of blockchain. So anytime somebody wants to update I have a ownership on land and I want to give that ownership to somebody else, right? So that part can be recorded in a blockchain, right? And if everybody does that, then that is a kind of agreed upon mechanism, and every land record in India will be part of a blockchain, right? So that change in ownership can be recorded in a blockchain. That is one part, only the change in ownership. That is one information, right? Second information is monetary information. Monetary information is, if my father is changing the ownership of that land to me, there is no monetary transactions involved, right? It is just a change of ownership. But if I'm selling this land to anyone else, right? Parallelly, there might be another one transaction. I'm selling this land to person B, and person B is giving me this much amount of money. So that amount of money in current state of how the blockchain is getting developed, right? That amount of money has to come through a cryptocurrency, right? So the physical cash transfer and the digital record transfer, right? Both of them till now have not been combined. But I believe that if you want to like kind of make blockchain mainstream, that means it can be implemented across India or across world, that system has to come. Some part obviously will there where the physical certain transfer will happen and the digital record transfer will happen, right? Both of them can be combined, right? So to answer your question, yes, that can happen where the land, like I get certain money in cash, or let's say I have a SBI account, whatever the land amount, right? Value of the land, that person B sends me that amount of money, that recording transaction, okay, yes, I have received this much amount of money in my account, right? On this day, 11th of August, right? That I can put in blockchain along with. So on 11th of August, I am transferring this land of this much, whatever the area, right, to person B, right? So now that part is recorded in blockchain. That can be done. That can be a use case also.
So the person whom I'm means selling my land, that I can't be seeing, means I'm not seeing him in physical manner. It will be in that what we can say uh, through blockchain we are selling, na sir? What you just said.
No, selling is not that blockchain. The transaction happens on over blockchain. So the record transfer happens over blockchain. So I did not get your question. What exactly your question?
Sir, I am asking, sir, the way in physically how we are selling the land. First of all, we sell the land, like ownership is transferred, then registry, then sale deed is happening, then land is registered on the name of other person whom I am selling. Like the same way, this also happens if we are going through this blockchain, or it is the different way. I am asking that question.
Yes, it will be like almost same way, only that the digital part of it, right? The record part of it, whatever documents you have, let's say that is 30 pages, 50 pages, 1,000 pages, right? There will be document where the ownership transfer has happened, right?
Yes, sir.
Rather than having those physical document or let's say PDF documents, if that can be transferred into a blockchain, right? That cannot be tampered with. Now what happens? I have a physical document or a let's say PDF of it, right? Somebody goes, makes those changes that, okay, this land is not in my name. Now what will happen if that record can be in a blockchain, that okay, person A on 11th August sold this land to person B. So from 11th August, the ownership of land lies with person B, right? Then it moves forward. So all this information, right? If that is in the blockchain part, because like I said, it is not that, okay, I can put everything in blockchain. Even all the movies, whatever has been recorded, everything can be put on blockchain, right? So there is not a limit of space, right? So I can put those record on blockchain. So now what happens? 10 years, 15 years down the line, nobody can tamper with the data. Not 10 years, 15 years, even after 2 days also, nobody can tamper with that data. Now what happens? In the actual reality, people keep modifying or tampering with those land records or any kind of municipal records, right? Because we do not have that security. If I can put those digital records in a blockchain, that cannot be tampered. Along with digital records, I can put the financial record also, right? I can say that either the financial transaction can happen over a blockchain, which is through a cryptocurrency, or through a physical currency like account to account transfer. But all that record, right? Let's say I have this physical deed, this registration and everything. If that put in a blockchain, right, and this is getting validated, right, then later on somebody cannot modify it. That is the advantage of blockchain.
Sir, means you are saying till now no one has done like this. Means yeah, or else it is done before, like this land concept.
Land records putting into blockchain.
Yes, sir. Yes, sir.
I don't
Have
think
anyone done this?
I don't think anybody has done it. People are working on that. Many startups are starting to work on it. See, right now, what happens? You have to get that government approval, right? Because land is something the registry and all those things, they need to get involved. It needs a lot many state government or the municipal and the tehsildar and all those people need to get involved. So that is the difficulty. So it needs a push from the state government or a central government to digitize. I think right now they're trying to do that. If you see the records from Niti Aayog, right? So they're trying to get into at least the part of it. So your every land record will be digitized and will be assigned a number, right? So gradually, I hope that they will get into that. Some startups in India are trying to help governments in that, but no, it is not implemented as of now. Maybe 3 to 5 years or 10 years down the line, it could be done.
Sir, in any other countries, they adopted the blockchain.
Blockchain in land records.
Yes.
Yes, that should be
Any
example.
other government?
Yeah, I think Denmark or Netherlands, they have already done it. Because see, the idea is already if your land records are digitized, changing into putting into a blockchain is the not be difficult, right? Obviously, you need some technical expertise, right? Right now in India, that is the biggest difficulty, right? Many land records still in physical documents. Not all of them have been digitized. That will be the first step, then moving it to see, because everything is linked. I cannot say that this part of the land in a city, in a rural village, this part of the land records are digitized, other part are not digitized. So I cannot put half of the records on blockchain, right? So all the things need to get into the blockchain.
Sir,
I
for
think in
election purpose, it has been started in foreign countries in Africa.
yeah. See, those are the things. Like those are the things you have to discuss during your presentation, right? So specific take certain use cases. Try to discuss how that can be implemented, right? How somebody, some country, some company have taken and used blockchains, right? To answer Asrit's question, I think Denmark or Netherlands they have already done because all the land records have been digitized, so they have started putting that into a blockchain. But in India, it will take certain time. But I think there are few startups. Few days back, I was reading an article. They have started putting that technology. I have a friend. So he has. I think he just graduated after doing MBA. He worked with PwC for 2 years. Then he started his own startup. So there is a where is that location? Mumbai, Pune. There is a Sayadri Farms, right? So they do this organic farming. So this person is working on blockchain part, right? So if you remember, I was talking about organic farming, right? Because most of the times what happens, somebody can just put an organic label, right? That might not be actually gone through all these steps, right? So he is trying to implement that part, blockchain part, right? in India on the organic farming, right? And he has done a use case in Sahyadri Farms. In case I am able to connect with him, I'll like kind of invite him to give you a talk, maybe one class on how they have implemented that in the Sahyadri Farms. So that is a use case in already executed use case in India on organic farming. Did I answer your question, Asri?
Yes, sir.
Okay. So let us get into the transaction part, right? So like I said, transaction can be monetary or non-monetary, right? So let's say person A wants to send something to person B, right? So how do you think that now, how do you think that let's say person A has a lock and key, person B has a lock and key, let's say briefcase, right? Certain information, certain money has to go from person A to B, right? Obviously, somebody can steal it, but unless they have the lock and key, they cannot open it, right? Now, how do you think that person A will send that briefcase, which contains certain information? You can think of one spy sending certain information to another spy, or one person sending certain money to another person, right? Without a central authority. Now, what happens? There is a central authority bank. So think about the money transaction. What happens? You have an account, person B also has an account. If I want to send, person A wants to send money to person B. Person A asks the bank sends the money to person B's account, right? It may not be same bank because all the bank networks are connected. You might send money from SBI account to ICICI account, right? But you have to have an account with some central authority, right? So that is the role bank is playing. Let's say I say that no, I'll not get into this. I'll not transfer information or money through banks. I'll do like without them, right? How to do that? If I want to send, I have a lock and key, and person B also has a lock and key, but both are different. So that is basically clue. Let's say you have a briefcase of documents. Another person, you want to send that briefcase to another person. How will you send that? So I've already given a clue that that part was not there in the actual problem, but I have given you that clue. Let's say you have a lock and key, another person has a lock and key. How that information can be transferred without somebody stealing that information or money.
So the public address of that second person must be available with the person sending. So with that, one can send.
But somebody can steal the briefcase, right? Can you please repeat? I did not get you. Let's say you want to send certain money to me, right? And you not take help of banks or anybody else. So how will you send that money? You can send through courier, right? You can send through different persons, right? Correct, because you are not taking help of this bank transfer and all those things. Or let's say I want to send the your final 10 term questions to this KIT University, right, from my home. How will I send that? I'll send through a courier, right? Now, how to make sure that somebody is not opening and stealing that document, or how somebody is not forging that? If it is money, somebody can just open it and steal it, right? Yes, Abhijit.
Sir, when you are sending those questions to the KIT University, then there might be some hackers who are taking that question. Sir, if you are encrypted that in a cipher text, then no one can read that, and after when it is reached on the KIT, then they have some private key. By that they can open your ciphertext into and convert into a plain text, and they can read that.
But how will I send that private key?
Sir, with that, you have a public key when you are sending that, and they have the private key of that public key.
So that private public, forget about that. So I have not got into that discussion, right? That will come back later on. So it is a simple question. Forget about some very big technology, right? You have a briefcase of document, right? You want to send to somebody else, right? How will you send that briefcase? That is very confidential document. You cannot go physically, right? You are sending through a courier. But if you are sending through a courier, it can be stolen, it can be. So you have to make sure that even somebody steals it, they cannot open it. So you have to secure it, right? Through certain kind of. So if it is a digital record, you will like kind of put some code and all those things. PDF documents, some PDF documents are, you need some code to open, right? Think about that, right? Or if it is a physical document, you'll put in a briefcase, you'll put lock and key, right? So I'm just talking about the physical document, right? So let us take an example of a physical briefcase. I have a physical briefcase. I want to, and it contains certain confidential documents, and I want to send it to, let's say, KIT University. I'll send it through a courier. Now my challenge is that courier guy might open it and steal those documents or understand what is written there, right? So I have to put a lock, right? Now, if I'm sending that, how will I make sure that KIT University opens that? All of you are getting my question, right?
Sir, via second courier, you can send the key of that briefcase to
Correct.
KIT University.
Correct. So that is one way, but there is a chance that that key also might be stolen. Somebody understand that that is a key which opens certain briefcase. That can be also stolen, right? So what you told
Sir,
is correct.
maybe
That
like,
actually used to happen. Yeah, tell me.
sir, it may be like giving standing instructions to KIT, like I am your employee and you have to open my briefcase through my employee number, employee ID only.
Correct.
So it is only known to you and it is only known to KIT.
Yes, so that standing instruction, how will I send? I have to send through certain.
Sir, it may be encrypted or it may be directly written on any paper or like anything, because a third party cannot encrypt that. A third party doesn't know your employee ID. So it's difficult.
But somebody can hack into that, right? Somebody can understand that. Somebody can kind of get that information, right? What, like, let's say your Gmail or your whichever your bank password, right? Most of the times it is getting hacked in that way, right? Somebody's user ID they get and try to put that into the whatever password they can generate, right? But yes, I do agree that there is a way. I can say that, okay, there is certain information which you can use, which only two persons know, KIT University and me. Yes, that can be hacked, that is true, but that is one way. That is other way, Ankita like said, you can send your key through a different courier, right? In this particular case, if I take this simple example, right? Think about the physical document. Physical document sending through a briefcase. I have a lock and key, right? It might be a physical lock and key, or somebody can just put a certain code, certain digit, and that number can be opened. Like Prabhu said, it might be so that your employee ID, which is only known to me and my kind of university, or certain numbers like that, right? Need not be necessarily employee ID, then they can open it, right? Other ways, and which used to happen a lot, right? In this way, I have a lock and key. What I'll do, person A will lock that briefcase. So person A locks the briefcase with the lock and sends to person B. Now person B, what he does, he puts another lock. Person B puts another lock in the briefcase document and sends back to person A. Person A opens her whatever the lock is, right? And send that document, briefcase document, to person B, right? Then in that case, what happens when the person B receives the briefcase? Now it is only his lock and the key is only with him or her, right? Think about in this way. I'll send a briefcase document to KIT University, to whichever, let's say exam department, right? So they will put a lock and send that back to me. Once it reaches me, I'll open my lock and send it again to KIT University. Now they'll open the lock and now open their lock, right? And get the documents, right? That actually used to happen. A lot of people say World War II and all those things. Lot many times this was a case when the documents or the confidential documents were getting transferred, right? Because obviously that time lot many like this computer usage and all those things did not used to happen. Physical document transfer used to happen, right? And this can be done for monetary. You don't know what is inside the briefcase. It can be money, it can be information, it can be anything, right? So that was one way, transacting secretly over a network, right? Is this example clear? Or any doubt on this? Anyone having any doubt? So this is a simple example of a physical document transfer, right? Which used to happen, right? Because I don't want to share the key, I don't want to send the key through a separate courier. That might be a chance that courier guy might take that key, right? So what happens? I have a lock and key, you have a lock and key. I send my document, I lock all the information in that briefcase, lock it and send it to you. You put another lock, send back to me. Then I open my lock and send back to you, and you can now open the documents, right? So that is one way. Second way, what Prabhu was telling, right? Once you get into this digital part of information transaction, right? There will be a shared key, right? And that shared key, in this case, let's say KIT University and me, there is a certain password, certain employee ID or certain number, which is known only to me and that university, right? So that is the part of private key cryptography, right? So that key part is that key which opens the document, right? Let's say it is a password, right? That password, again, that can be hacked. That is another challenge which we'll discuss just into the next slide. But at least that gives you certain security, right? So you are not sending that key with somebody else. You are not sending that password. That password is already known, right? That has been agreed upon between me and the KIT University, right? The day I joined or the day we started interacting. Then anytime I send a document, I put that encryption, and anytime once they receive the document, once they receive that information, they can open through that key, right? So this is known as a private key cryptography, right? Again, this is very simplified version. I'm not going into the technical details of it. Imagine you have a password, right? A PDF document, and that password is shared between me and you, right? You know the password. Anytime I send a document, you 45 people only can open those documents because you know those passwords. Other 300 students cannot open those documents, right? If I encrypt a PDF document and I share that and say that you do not share this password with others, right? So again, to give additional security, I can change that private key every day. I can create certain random numbers every day, which is only known to you and me, right? So that other people cannot guess it. Because let's say employee number, right? Somebody somehow, if they find out the employee numbers, because that details also visible, right? In a SAP system, ERP system, it is visible. They'll be able to know it, right? So that is the private key in cryptography, right? That password which opens a PDF document, right? Itself can be known as a private key, right? Is this part clear?
So that random part generation, I couldn't understand.
Yeah, so the key, what we are telling about, right? The key can be anything, right? When I talk about digital numbers, right? Rather than my employee ID, because employee ID, if I say that every time I'll be using employee ID to encrypt data, right? What happens? Somebody, if they are able to know that, okay, these documents are always encrypted through a employee ID of that person, and somehow they got into KIT database and get all employees employee ID, right? Let's say there are 10,000 employees, and they keep trying that which employee has encrypted it, right? Some employee would have encrypted, some employee would have written the document, and once that ID is given, that document they can open and see it, right? To avoid those challenges, right? So what I mean to say is that the shared secret key, right? So when I say shared secret key, that is agreement between one party and another. like Prabhu was telling about, if I'm sending one document to KT University, so we have agreed upon that, that will be my employee ID. But let's say that is your end-term exam details, right? Some of you guessed, some of you able to hack into the KIT system, or somehow you got my employee ID, right? Now you get the document and you are able to open it through that employee ID. To avoid that kind of situation, right, where somebody can guess, somebody can hack into your shared private key, right? Most of the times it is a random number generator, right? Same random number generator which is utilized by me and KIT University. Every time I'm sending certain documents, right, that random number I'm sending, or that random number will encrypt that document, right? And same random number will be shared with the KIT University, right? And they can open the document. So what will happen today? You might be able to open the document. Might not happen tomorrow, because tomorrow that number has changed. It is no longer my employee ID. Day after tomorrow that number has been changed, right? So the secret key itself is getting changed every day. That is the random number part.
Yes, I understood.
This is people used to use that, and still people use this, right? This is a private key cryptography, right? Then whatever we use in a blockchain, right, is little bit more secure. That is known as a public key cryptography. You remember, like we discussed in the before 2 slides, right? There is a log, there is a key, and those things are getting encrypted, right? So what this person do through this private key, right? She creates a public key, right? And this box, whatever money, whatever information is getting logged, right? And that will be transacted to other person, right? So think in this way. I have let's say I have my employee ID, or not employee ID, I have certain number, right? That is very confidential. Nobody knows it, right? I have written down in a piece of paper. So actually that happens if you are storing your digital currency in cold storage, right? Like kind of a cold wallet, right? So in that case, they give you certain numbers. That is your private key. Ideally, you should not you store it inside your house so that nobody knows it, right? So you have certain number which is very confidential to you, right? That is a private key. From private key, there will be, so if I put that private key in a random number generator, right, it will generate a public key, right? At any time any transaction happens, that is through a public key, right? So how does that happen? So here what happens? So in earlier case, there used to be only one key, private key only, right? Now we are adding another bit of security layer. So what we are doing, all of you will have your private key. That private key can generate public keys, right? Anytime you are making any money transaction or information transaction, right, you are using that public key, right? So in the earlier case, what used to happen? You have only one private key. For each transaction, you used to encrypt with that. You might change that private key very often through a random number generator, but still you have one private key. Anytime you are making a transaction, you have only one key, private key. Now what happens? You, in the public key cryptography, you have a private key. That private key will help you to generate many public keys, right? Then that public key encrypts the message, right? So let me show you through an example, then we'll come back to slide part, right? I think I had given you the link in the earlier class. Please open that. Okay. Let me share my screen. Okay. So you have this private key, right? This private key here, it is given in this form. Most of the times, let's say you write down certain number. Let's say you, whichever is your favorite number, like 7 digit or 8 digit. Let's say, okay, some number 8 digit or 10 digit you write 78908789, right? Let's say this is your private key, right? This you don't share through email, do not share at all, right? this, let's say in any blockchain, right? Each one of you will have a private key, right? And that will be only known to you, right? Through this private key, right? Here only one public key is generated, but practically or in reality, through that private key for each transaction, I can create, anytime I'm doing a transaction, I can create a new public key, right? So let's say I want to, today I want to transfer certain money or transfer certain information to all of you, right? And this is my private key, right? This is only known to me, right? If I put it into a public domain, obviously my identity is gone, everything is gone. This number is private to me, so I'll generate a public key. So this is the key generation part, public key generation part from the private key, right? Again, this is through a random number generator, right? So if I put this private key, a public key will be generated, right? Is this part clear? I have a private key and it is helping me to generate a public key. Is this part clear? Or any doubt on this?
Yes, sir.
Yes, sir.
Now what happens? I'll go. Now I want to do certain transaction, blockchain applications in business. Okay, so before that, let me show one thing so that we are in the same page. So this is my private key 78908789, which is very confidential to me. With that, I have generated a public key, right? This is a big number, but just remember the first 3 or 4 digits, right? 043E1, right? 043E1, right? Now what I go, blockchain application in business class today. Let's say this is certain information I want to send to somebody. Through this private key, okay, so I have this private key. So you remember this is the private key I had given earlier. Let's say this is a very secret message, right? I want to send it to somebody, some of you, right? So what I'll do, I'll encrypt this message with my private key. How do I do that? I'll sign it, right? So this message is now encrypted. What basically happens once I say that, okay, rather than blockchain application in business class today, let me change this. I'll say that who is there in the first list? Let's say Asri. So I'll say that I'll pay Asri INR 5. Okay. On 14th August. Let's say this is the transaction happening, right? INR 5 on 14th August or INR 5 today, whatever it is, right? So this is a transaction which is happening over a blockchain. So I'll sign it with my private key, which is only known to me. This is my message signature. So I'll sign it again because it has not changed. Okay. 3044022, some number, right? So what actually miners do, right? For my message, right? Through a private key, I have generated a signature, right? Initially, if you remember in the keys, what we had done for my private keys, there was a public key which started with 043E19, 043E19, right? This public key 043E19, whatever the digits, right? This is everybody knows. If I am in a blockchain, you are in a blockchain, they will not know that Piyush is there or Asrit is there or Ankita is there or Alisa, whoever is there, those 45 people, right? But they know that these are the public key addresses. These are the public keys of person who are available on the blockchain, right? This is known to everybody, right? Now what happens? So I'll sign it again. So this is my message signature. As a miner who verifies the transaction, what they'll do? So they know that, okay, this person has sent, right? And this is the public key. And this is the signature, right? So now what happens? They'll verify that whether this transaction has been originated from the same person who source and the message information is correct. Whatever, like let's say INR 5, INR 10 is correct. So they'll verify, they'll just, whatever the algorithm is there, right? So they'll verify it. So if it is green, that means this message is written by this public key, whoever is the owner of this public key, right? So see the difference between this. Minor do not know my private key, but they know everybody's public key because this is publicly visible, right? But what I did, I signed the document or I signed the transaction with my private key. I signed the transaction with my private key that I'll pay 5 rupees to Ashrit on 14th August. That I have signed with my private key. Minors, when they're verifying the transaction, they are verifying the transaction with my public key. So that is the meaning of public, right? It is visible to all of you. If minor now what they do, rather than this public key, I'll show the other part of also, the address part. Now what they'll do, somebody pays the minor, or Ashrit pays to the minor, they say that, he has written 5 rupees, rather than 5 rupees, put 5,000. Okay. So this is the not the block part, this is the transaction part, where somebody is trying to hack into transaction or changing certain information on the transaction, right? So what I have done, I have put my message that I'll pay INR 5 rupees to Ashrit, and I have signed it through my private key. That is the signature. And my public key is visible to all of you, right? Now Ashrit or somebody else, some minor is changing certain information here, right? If they do that and they try to verify, it will not get verified. Because the information what I had signed it is not matching. So this verification part is the first step when minors do the verification. That okay, whether the transaction which is happening is correct or not, or whether the information has been tampered with. If this part is verified, then that verified transaction will get into the block. Then the block again will get encrypted, right? The transaction verification is the first step of any blockchain. Yeah. Is there any question on this?
Sir, the message part will be seen to all the miners.
Yes, yes. Message part in the sense it will be again encrypted. I have just written it here, but again the message part itself is encrypted.
Okay.
So you'll not know that okay whether it is 5 rupees, 5,000 rupees, and something. So you'll know that okay. I'll show you a monetary transaction. I think the next example is that if you see transaction. So let's say, okay, now the next part, right? How we have discussed as of now, you have a private key which is very confidential to you. You have written down in a piece of paper, and you will, that is only one key per person, right? And obviously you can change that later on, but let's say right now you have one key. With that, a public key will be generated, which is visible to all of the persons who are in blockchain. From public key, there is something called address is generated. So we are adding another layer of security, right? So now what happens? Let's say this is me. This is this person, me, right? So it will not show that Piyush is sending money to Ashrit, and this is Ashrit or somebody else, right? Whom I'm sending the money. And I'm sending, let's say, $20, right? And this is my private key. So rather than writing that, okay, I will pay Ashrit this much amount. Now what happens? I want to send $20 to Ashrit. We have added another added layer, right? So from private key, public key is generated. From public key, address is generated. Now what happens? Rather than identifying whether Piyush is sending to Ashrit, this address money is $20 is being sent from this to this account, this address, right? So in blockchain, if you see in transactions, if you go to that blockchain explorer, this information is visible. From this address to another address, this much amount of money is getting transferred, right? Now I have this private key. So what I'll do, I'll sign it. So this information is signed. Now what happens? This message, somebody who through my public key, right? One minor, right? Will verify this. Then it is verified. So rather than $20, let's say he puts $200, right? So if we try to verify it, it will not get verified. Or rather than here $20, so what we'll do, rather than this address, let's say his address starts with 05. right? You try to verify, it will not get verified. So you cannot make any changes in the transaction. So miner only can verify, they cannot make any changes in the transaction. In that way, transactions are secure. Otherwise, what will happen? So $20 from me to, let's say, Asrit, I have put that as a transaction. So miner, what will do? Rather than this address, he will put his address, whatever his address is generated, he will put his address. Rather than 20, he will put $2,000 and verify it. So from my account, $2,000 will be deducted and will be gone. So this is how the transactions are secured through a public key cryptography. So all of us, if we participate in a blockchain, we will have a private key. From private key, public key is generated, and public key addresses are generated. So in blockchain, whichever transactions happen, it is basically from one address to another, right? From address A to address B, or whichever address you can see, those addresses are again encrypted. And nobody can change those addresses in a transaction. If they change, it will not get verified. Yes, Ankita.
So that means Ashrit will share his public key to you for the transaction, and you have to type it down this like this only, like 0466.
No. If I want to send money to somebody else, right? If I just know that name, right? Public key, right? It is not that I have to type somebody, right? So if the public key I know, like the account transfer, right? So I know the public key, I'll just select that public key and send that money to that person, or I'll select that address. I need not have to type down. So if your question is whether I need to remember, the obviously I cannot remember. And these addresses will keep changing. Because remember, for each transaction, your public key can change. So with a private key, you can create thousands of public keys. Right now, this is, let's say, this is the address of Asrit. For the next transaction, you can change this. But yes, this address should be available to me. That I should know that this address. But again, I need not have to type that. That will be available in the blockchain.
So every time a new public key will be generated. So at every transaction, he will have to provide his public key to you.
Yes. So generally it happens like that. It is not that he has to send to me. It is open, right? It is open. Everybody can know this. These are the public keys which are available right now. So public keys are public. That means it is visible to all of us, whoever are in the blockchain. Addresses are also public, which is generated from the public key, right? These are openly visible. So if you go to a blockchain explorer, you can also see that from which address to another address, some amount of money are getting transferred. Anybody can see. Is this part clear or any doubts? So this is actually a blockchain, right? If I talk about a blockchain, let's say Bitcoin, right? So this is the first block, right? Here A, this is one miner. This is the information what he has. This is the block A. So in the starting of the block, let's say Satoshi Nakamoto, right? So he has got $100, right? $100 were created and was given to his address. In the second block, what has happened? So this transaction, again, another $100 is given to that person, Satoshi Nakamoto, and he starts giving $10 to somebody else, $20 to somebody else, $15 to somebody else, $15 to somebody else, right? So see, this is the account 04FE1, 04FE1. This is the person who started the, so anytime any blockchain starts, right? The initial genesis block, somebody will, some coins will be generated, some money will be generated, right? Somebody will first hold that amount of money, right? Think about the RBI, right? When money is generating 2,000 rupees, right? RBI started that 2,000 rupees, right? At the beginning, 2,000 rupees will get manufactured in the, like wherever we have that manufacturing facility, right? Printed, right? Money is printed and will be sent across to different banks. Then people will go and collect 2,000 rupees from the bank. If you remember that demonetization happens, right? Same situation here. In the first block, $100 was generated. In the second block, another $100 was generated. Parallelly with that, that person who got this 100 plus 100, $200, he started sending money to whichever person. Let's say he wants to buy a pizza, right? $10 is sent to that pizza owner to buy a pizza. And actually it happened, right? The first Bitcoin transaction, I think they paid 20 or 27 BTC to buy 2 pizzas. Right now it will be in crores, that 27 Bitcoins, right? But obviously in the 10 years, 15 years back, nobody like kind of understood that value, right? So initially, let's say that person wanted to buy certain pizza, some pizza, right? He gave it to this address, signed it, right? And $10 was given to that. $10 or 10 Bitcoin. Here it is written is dollars, right? $20 to somebody else to buy something. $15 to somebody else, right? So now what happens? Money is getting transferred from different people, right? Think about RBI. When 2,000 rupees first day, none of us had 2,000 rupees. What happened? 2,000 rupees got into thousands of banks in India. From thousands of banks, we went and withdrew money, or from ATM we withdrew money. Then transactions started happening between us, right? Physical 2,000 rupees. Same situation here. Digital money is there. Somebody first started with that $100 or $200 and started giving to others, right? Then this person, whoever is this 04cc, who is this 04997, right? 04997 AC, right? This person who got certain amount of money is sending to this other person 04B4 $20, right? In the third block, right? So transactions keep happening across the blockchain, right? Once somebody gets money, you might invest certain amount in the, let's say, certain coin exchanges, or somebody somewhere to buy certain things, right? Let's say you want to buy Tesla. In between, Tesla allowed to buy a vehicle through paying Bitcoin. So you'll pay that money, whatever, 1,000, not 1,000, maybe 10 or 20 Bitcoin to Tesla, and will get the delivery of Tesla. So what happens? That 20 Bitcoin is going from your account to Tesla's account. So that is one transaction, right? And each of the transactions are getting signed, right? Now what happens? As a miner, they will verify
So
this.
your voice is breaking.
Am I audible? Just a moment. Is it better now? Hello?
Yes, sir. Can you repeat that part, like it was breaking? So.
Yeah. So what happens? I was talking about the creation of any blockchain, right, or cryptocurrency, right? So imagine like 2,000 rupees. Am I audible now, or is it bad?
Yes, sir. Yes, sir. Audible.
Okay. Think about how those 2,000 rupees got into circulation, right? 5 years, 10 years back, those were not into circulation, right? The demonetization happens, and RBI or the government decided, okay, 2,000 rupees will be in circulation. The money was printed. Then they were given to different banks. From banks, it came to different people, right? Same situation here. In the first block, right? Any blockchain, there will be always a first block, right? $100 or whatever that cryptocurrency denomination, right? It was created, and whoever the owner or whoever the beginner of the blockchain, right? Whoever created that blockchain, he got that money, right? Then he started sending that money to different people who are part of that blockchain, who are participating in that blockchain. So from 100, next block also he got another $100. So right now he has $200. From $200, he sent $10 to this 04cc, $20 to 0499, $15 to 0422. Like that, he made 4 transactions, right? And all these transactions right now getting listed in the block number 2, right? There will be a miner, somebody like you and me, right? They will make sure that this transaction is valid, right? So they'll just click the mining button, right? Why it is taking time? So now what happens? Rather than this $10, what has happened here, right? Now what I'll do, I'll make it. Okay, I'll make the changes here. So now what happens? The miner will say, rather than 04D40, let's say his account is this 0499. Okay. So I'll copy that. I'll put it my account here. See what happens. The signature becomes invalid. That transaction which was from this person to another person, right? If I put my address or somebody else's address, that transaction becomes invalid. Or here, rather than 5, let's say I put 15, that transaction gets invalid, right? So in a blockchain, those transactions itself needs get verified. Once they get verified, right, then only they'll get into the block. Right now, because these are invalid transactions, this block cannot be created. Because I have changed certain numbers here, I have changed here addresses. Right? Yes, yes. Yeah, go ahead.
Sir, after the verification is done, the
Hmm.
block will be added to the blockchain only when that random number will be generated, no, sir? The nonce number.
Correct, correct. Nonce is here. So 29164, this is the nonce already mined, right? So if I change this, right, this is not verified. So I have to, so this is not verified. So see what happens here. He has written a small code to mine, right? But what happens in a blockchain? That code you have to write as a miner. You have to find an algorithm, or you have to create an algorithm which will be able to, because see this right now. Do one thing. Here make some changes. $1,000. Mine. Okay. So see the nonce is changed, right? Now what happens? I have changed certain in the beginning itself. Rather than $100, I made it $1,000, right? So 124672 has happened, right? Now what happens? Due to this, right? Here this hashes and everything has changed, right? Now what will happen when this block or transactions are getting generated? The puzzle what I was talking about. So you have to find a number, that is number ones, right? Which will validate this block, right? Validate this whole block, right? So what I can do, if I do not create an algorithm, if I do not know a coding, right? Let's say I want to do it manually. I'll try different numbers. I'll keep trying different number, different guesses. So that guesses is hash rate, right? The number of times I'm making guesses as quickly as possible. That is something known as a hash rate, right? So to finding this random number, but obviously I cannot manually guess, right? So all of the miners will have certain using certain algorithms. Like in this blockchain demo, he has created a code, right? So if I put this mining button, right, it will take certain seconds, few seconds, but it will give me that nonce, right? 18,548. So this, like I discussed earlier, right? This puzzle is nothing but finding this nonce, right? Which will, like in this case, the puzzle is you have to find a random number. The random number is number ones or nonce, which will create a hash starting with 4 zeros. For this demo, it is 4 zeros. In actual Bitcoin, it is 19 zeros. So for this demo, the algorithm is created in such a way that to verify or to validate this block, you have to find a nonce or a number ones or this random number, which will create a hash starting with 4 zeros, right? So that is the puzzle part. So that we discussed in the last class, right? What today we are discussing, each transaction also need to get verified or validated, right? With the signature. If somebody makes certain changes in the transactions, right? Miner cannot make changes to transactions. Otherwise, what will happen? Miner will put their addresses and all the money will go to them, right? Because there is no central authority. To avoid that, right? each of wheel, whenever you are making a transaction, you transaction are getting signed. So that is known as digital signature. So due to this digital signature, right, I cannot make any changes here, neither in the addresses nor in the transaction amount. Right. So minors, those who are basically the question is who will guard the guardians. So now the code, the algorithm is guarding the guardians, because unless that is not there, I cannot just believe they will be all honest. They just can just put their addresses and take my money. And once it is in the blockchain, it is validated and block is validated, money will go to their account, right? So that part is taken care by this public key cryptography, right? And this part, encrypting the block, is taken care by this SHA-256 algorithm. So to finding this hash, which is basically 256 bit or 32 byte, right, to a random number, is basically a SHA-256 algorithm, right? So that is the encryption of block, right? Block is a collection of transactions. Each transaction is validated, verified. Once the transaction is verified and validated, this green is there, right? They'll get into a block. Now block is getting encrypted. How the block will get encrypted? So we have to find a random number which will create a hash with 4 digits, right? The same situation here, right? Now I do not know what is this random number. I have to find a random number which will kind of, so right now if you see hash is with A957, starting with A957. This is why it is not validated. I have to find I have to change this to 4 zeros, right? How it will be changed? Every time I change a number here, let's say I put it 1. So this number is changing. So let's say I put 1, 2, 3, 4, some number, right? That is starting with E6. So I have to make these cases so that it will start with 4 zeros, right? So obviously it cannot be possible doing manually. So most of the miners, not most of the, all of the miners use certain algorithms which basically run in the computer, and once they mine it, right, it will take certain time to find the hash. So right now the mining process is going. So 91790, if the random number was 91790, it will start with 4 zeros. Now the block is verified, right? So that is the puzzle they are solving. So finding this random number, finding this nonce, which will give a hash of 4 zeros, right? So is this part clear? So transactions getting verified through your digital signature. So digital signature is nothing but you are signing your document or transaction through your private key, and it will get verified through your public key. So that is why it is known as public key cryptography, right? Any transaction in a blockchain gets verified, right? Once they get verified, they will get into a block. Then block need to get verified, and block verification is done through this SHA-256 algorithm, which is nothing but finding this nonce, right? Finding this random number, which will create a hash. Here in this case, 4 zeros, right? Again, depending upon the blockchain, that number of zeros will be different, right? This is the main kind of logic behind a blockchain. And your identity also is encrypted, right? So I do not know who is sending money to whom, right? That's why a lot of government legal authorities are against blockchain technology, right? Because unless I know who this address belongs to, because knowing this, I cannot find out who is this person and from which location he belongs to, right? So that's why a lot of conflict is happening. Many government are not allowing blockchain. China right now have started, right? Clamping down all those mining rigs. Because unless I know who are the person, let's say
But
that
Miami has already started its own.
Yeah, the other country, Ecuador or somebody allowed, right? So the point is, if all the governments allow, India right now it is in a dilemma. Sometimes they're telling they will not allow, sometimes they're telling some part they will allow, right? So the technology is good. So the point is how we are going to use it. So if somebody is using it to drugs transfer or paying certain ransom money, that is a bad usage of technology, right? So we have to reach a situation where there will be a honest or a transparent usage of this, right? Not for illegal means. Yes, still like some locations, Ecuador, whole country, they have allowed blockchain. Right? Not the blockchain part, basically cryptocurrency, right? Understand, cryptocurrency is different from blockchain, right? I hope that is clear. Cryptocurrency is the money which is transacting on the blockchain. Blockchain is the technology behind cryptocurrency. Then blockchain I can utilize for many, like I said, land records. I need not have to pay the money in the blockchain itself. I only will store or digitize the land records in a blockchain, right? In that case, I may not have to need any currency on that. Organic farming, this IoT, right? So those will be certain kind of application where I did not have to only depend upon the cryptocurrency, right? Is there any doubt on this? So I know I have already like spent all the time.
Yes, sir. Sir, am I audible?
Yes, yes. Good.
Yes, sir. Sir, the thing is ki we can't distinguish blockchain and the incentive that is given to the miner, that is Bitcoin, the cryptocurrency, because the miners only get those money as an incentive. So that thing get into the head that blockchain technology matlab Bitcoin.
Yes, what you said is, see, the idea is how you are paying the banks. The bank is charging you certain amount. They are taking yearly or monthly certain amount of money from you. It may be very small, right? But they are deducting from your account, right? And that money, maybe if it is Indian, it is INR, and they are deducting it. Right now, what we have done, we are telling there won't be any authority. Let's say for the land records right now, who is authorizing it? Municipal, like kind of municipality or the whoever the auditor, right? If the government says we'll do away with that because it is taking a lot of time, it will be central system. There will be a blockchain, right? If let's say they allow public like you and me to verify the records, right? Now we will not do it free, right? We'll get certain money.
Yes, sir.
Current system in such a way is that to get that money, so to get that transaction fee.
Sir, initially it is started as an incentive model for the miners, but now the money they are using as a as saving or transaction, or it's they are using like stock or so.
Stock in the sense, see, that is something because limited supply, right? That's why like value is increasing. If I say gold, why do you think gold is costly or diamond is costly? Because it has a limited supply. Unless there are certain things which is in limited supply, that value will, you never know the certain of their value. INR, dollar, tomorrow government starts printing more money, the value of the money will decrease, right? That is one advantage with the cryptocurrencies, right? Not all of them. Some are unlimited supply. Then there are ways to limit the kind of do away or control the inflation. But most of the cryptocurrencies have a limited supply. I think in Bitcoin it is 21 million. 21 million Bitcoin. No matter what happens, there will be always 21 million Bitcoin, right? So now same thing. No matter what happens, we know that these many quintals or these many tons of gold will be there. Now the challenge happens, who will own that gold? But I will not be certain that, okay, Indian rupees, how many Indian rupees will be in circulation? Tomorrow government prints more money, it will be more circulation, right? But tomorrow government takes like demonetization happens, less circulation, right? So that is the
Sir, one more advantage or disadvantage, I don't know, but the country whose currency value is low, they are taking advantage of this cryptocurrency to do the transactions. I think Malaysia is completely using Ethereum to do his transaction. Am I not wrong?
Not sure
Oh, sorry,
whether Mauritius might be, not Malaysia. Ecuador has started all of the transactions in Bitcoin. Yes, that is one case because if your money is very kind of devalued, right? Like it happened with Zimbabwe, right? Hyperinflation, right? One good way is to, rather than printing money, you move into the new system of transaction, right? But like I said, cryptocurrency is only the one part of it. It is lot in discussion because that was the part which started the blockchain technology, right? We had solid 10 years or 11 years to work on it. But the course is not only about the cryptocurrency. Again, we'll discuss that in detail. But again, those things are later on. Any doubt on these two parts, how the transactions are validated and how blocks are validated? Because I'm repeating that because those are the two important concepts. One that is clear, other part will be bit easier, right? Which we'll discuss in next class, right? The consensus mechanism, how the miners get into consensus, right? But this part, how the transactions are validated by public-private key cryptography. Blocks are validated by your SHA-256 algorithm, right? If still you have any doubt, please go through the demo, which I have shared the link. Please do ask me in the next class, right? So once that is complete, then we'll move into the little bit easier parts, right? Any last question?
Excuse me, sir.
Yes.
We have the next class, so can we
Yeah,
leave?
yeah. Yes, please go ahead. Okay.